Hello everyone, my name is Diksha and I am from the Bodhi Academy. I am taking 12th standard chemistry topics which will be there for upcoming exams. So today I'll be starting with the aldehydes, ketones and carboxylic acids chapter, which is one of the important organic chapter from chemistry. Okay, so let us start with the basics of this chapter, that is the nomenclature, introduction, and both the nomenclature. So aldehydes, ketones and carboxylic acid. Okay. Now this aldehydes, ketones and carboxylic acids are important functional groups that we have already studied in our 11th standard and also in our previous chapters while preparing the alcohols, phenols, then haloalkanes, haloarenes. So in these chapters we have already seen. So we will study more details about the aldehyde, ketones and carboxylic acid in this chapter. So let us start. Now aldehyde. Now for every compound there is general formula. So for these compounds also there is general formula which we will be denoting. So for aldehyde, how to denote aldehyde or how to write the general formula of aldehyde. So aldehyde basically fall under carbonyl compounds. Aldehydes, ketone, carboxylic acid and some other compounds, they fall under carbonyl compounds. Now what is carbonyl compound? Carbonyl compounds are the compounds which are having C double bond O group in their compound. Okay, so if I consider aldehyde, the formula is RC double bond O H. So this is the basic formula of aldehyde. It is a general formula. Then if we consider ketone, then ketone is having R C double bond O R. Okay. Then next is carboxylic acid. So carboxylic acid is having formula R C double bond O H. So if you notice in all three general formulas we have C double bond O in their compound. So that's why we call them as carboxylic, we call them as carbonyl groups. Okay. Furthermore, we can have amide. Amide is also a carbonyl compound in which we have the formula as C double bond O NH2. Okay, so this is the formula of amide. Then acyl chloride, which also have this group, that is acyl chloride is represented as RC double bond O X. So this is a formula for acyl chloride and this also comes under carbonyl compound. Okay. Then next is ester. Ester formula is RC double bond O R. Okay, so these are some of the important carbonyl compounds and from this we will study in more detail about the aldehydes, ketones and carboxylic acids. Okay, now the question comes is why we have to study these three main compounds or why we have to study the carbonyl compounds. Okay, so here the answer is we can see the applications of these compounds in many our day-to-day life, like that is in fragrances, when we or in as a flavoring agents. For example, vanillin. Vanillin is extracted from vanillin is a compound which is extracted from a plant, that is vanilla, and that it is used to give it is used as a flavoring agent. Okay, then many other compounds we use as a we use in a fragrances or in pharmaceutical industry. So this can be used for that purposes. So that's why all these compounds are very important to us and that's why we are studying them. Okay, then talking about ketone. One famous type of ketone, that is acetone, you must have heard. So that is used in also nail polish remover, which most of the girls they use nail polish remover. Okay, since it is volatile, you can see. Then aldehydes, as we have seen, salicylaldehyde and most of the other aldehydes we can use in the pharmaceutical industry as well as in our day-to-day life. Okay, in many things. So that's why we are going to study about this. So let us start with the nomenclature first. So there, since you have studied the two chapters of organic before, that is haloalkanes and haloarenes and alcohol phenols, in that we came to know that there are two types of nomenclature, that is IUPAC nomenclature and common nomenclature. So we can write the name in two types. Okay, so here also the rules go same, that is the rules for nomenclature will be same. So let us start with the nomenclature. So let us take simple aldehyde first. Okay, so if I have this aldehyde HCHO, okay, then the common name of this is, common name ends with aldehyde only, so the common name of this is formaldehyde. Now common names doesn't have any rule, so they are given directly. That's why there is no such trick to remember that name. But IUPAC name you have to write according to rule. So common name of this is formaldehyde, and IUPAC name is, since there is one carbon, the name will be methanol. Okay, so this is methanol. So if I have CH3CHO, so in this I have two carbons. CHO group means aldehydic group. Here also CHO. So if you see CHO group, that means you are talking about aldehydic group. So CH3CHO, there are two carbons. So here the name will be ethanol. Okay, so IUPAC name will be ethanol. Then next, from aldehyde only, if you take C2H5CHO, then this will be propanol. So it depends on how many number of carbons you have in the compound. Okay, then if you talk about ketones, then ketones, if I have this compound HC double bond O H. Okay, so here actually to form a ketone, we should have at either side of the carbon we should have R group, but here we have H group, no, so that's why this is very unstable, so this will not form. So we have to write R group on both the side of the carbon. So RC double bond OR, this is general formula. According to this, if you write the simple ketone, that is CH3C CH3 C double bond OCH3, the common name of this is acetone. Okay, so the common name is acetone, and the IUPAC name will be, it will, now you have to number and you have to see the functional group. So while numbering 1, 2, 3, 3 carbons are there, but at second carbon we have ketone group, that is C double bond O, so the name will become propane 2O. So this is a simple name of this ketone. Okay, then if I take further CH3 C double bond O C2H5, that is CH2CH3. Okay, then here we can see that there are how many total number of carbons? 1, 2, 3, 4. 4 carbons, but at second carbon we have this ketonic group, so the name will be butane 2. So this is the IUPAC name of this compound. And third is carboxylic acid. Okay, carboxylic acid name ends with oic acid. So let us take one simple example, CH3COOH. So here we are having two carbons. So the name will start with this, eth. Okay, then ethane. Ethane is the name of the carbon chain, but we have acid, right? So the name will be ethanoic acid. Then if you take CH3CH2COOH, the name will be, since there are 3 carbons, the name will be propanoic acid. Okay, so carboxylic acid's names are you have to write this way. Okay, now let us take some compounds, some examples of compounds, and we will try to write the names. So first I will take CH3 C double bond O H. Then next is CH3 CH2 CH2 CH Br CH CH3 CH2 C double bond O H. Then Next is CH3, CH2, CH, CH, C double bond O, H. Okay, we will try to name these compounds. So the first compound is CH3, C double bond O, H. Okay, so name of this is, IUPAC name will be ethanol. Okay, since we have two carbons and this CHO aldehyde group is present, so suffix will be al and the name will be ethanol. Okay, this is very easy. If you go to the second one, okay, now let us start the process here. We have a long chain, long carbon chain, and to that chain we have functional group attached along with the substituents. So first we have this, first we have to identify the functional group. The functional group is aldehyde group, which is CHO, and our substituents are bromine and methyl group. Okay, and the longest chain numbering will start from right side. So 1, 2, 3, 4, 5, 6, 7. So the carbon chain contains 7 carbons and our substituents are at third and fourth carbon. So but here the question comes which substituent to write first, because we have two substituents. So here we have to write according to the alphabetical order. So bromo, B will come first, so the name will start with bromo. So how to write the name? Since aldehyde is there at the first position as a main group, so name will end with the aldehydic suffix, so that is al. And substituent numbers will come at the first. So 1, 2, 3, 4. At third and fourth position we have substituents. So the name will be 4 bromo, 3 methyl, 1, 2, 3, 4, 5, 6, 7. So 7 means heptane. So heptanol. Okay, so 4 bromo, 3 methyl heptanol will be the name. Okay, so here what you have to remember, first you have to count the number of carbons, then give number to all the carbons, and you have to start from the proper, from either left or right according to the priority group, and then you have to see the substituents and arrange them accordingly. Okay, the next is benzene ring with CH3 and CHO. So here the main group is CHO, the numbering will be from here. So 1, 2. So here the name will be, since this is the main group, the name will be 2 methyl. Okay, so this acts as a substituent and this as a main group. So CHO is attached to the benzene. So CHO attached to the benzene, the name is benzaldehyde. So it will be 2 methyl benzaldehyde. Okay. Then next is having double bond. So numbering will start from here because this is having main functional group 1, 2, 3, 4, 5. So here we have to start numbering 1. There are 5 carbons and there is double bond between these 2 carbons, and here we have the main functional group. So the name will be, since we have 5 carbon, pent. Now we have double bond, right? So the name will not be pentane, so it will be pente. So the name will be, at second carbon we have double bond, so the name will be pent 2 in. Okay, pent 2 in, and first position we have aldehyde group, so it will be 1 al or al. Okay, so here the name will be pent 2 in al or pent 2 in 1 al. Okay, since we are having double bond. So this was about the aldehyde. Next we will see about the ketones, the name of the ketones. So here the names, okay. So first we will take CH3, CH2, C double bond O, CH3, then Then third is so we are having 4 examples here. So let us start with the first. So this is a simple one. Start numbering first. So here we have 4 carbons. So numbering will start from this side by which the carbonyl group gets least number. So if you start from right side, carbonyl group will get least number, 2 numbers. So 1, 2, 3, 4. So the name will be like, we have C double bond O. So carbon, this is the carbonyl group. Here we have at the second carbon. So the name will be butane 2-one. Okay, so name will be butane 2-one. Then the next compound is the benzene ring attached to the ketonic group. So on one side of the ketonic group we have aromatic and other side we have aliphatic compound. So here the main compound will be aliphatic one. Why? Because the carbonyl group is in that group. So here this will be main compound, and to this compound we have what attached? We have this benzene ring attached. Okay, so the name of this will be, since now this is first carbon, so this whatever is attached, the group is attached, is to the first carbon. So the name will be, now this becomes substituent, okay, because carbonyl group is directly attached to the aliphatic group. So the name will be 1-phenyl propanone, because 1, 2, 3, these are 3 carbons, so propanone, so, and this is attached to the first carbon, so 1-phenyl propanone. Okay, then next is this compound in which we have the ketonic group at this position. So let us start numbering. This will be 1, 2 and 3. So at third position we have substituent. So the name will start from the substituent, that is 3-methyl. Okay, then this is pentane, no? So 3-methyl pentanone. Okay, now since the ketone group is at first position, name will be 3-methyl pentanone. Okay, and the last one from ketone is this group. Here we have to start numbering from this 1, 2, 3, 4, 5. Okay, so here there are 5 carbons, so name will start from pentane. So pent, now there is double bond, so pent 3-in-2-on. Okay, so since we have double bond at the third carbon, the name will be pent 3-in, and at second carbon we have ketone, so 2-on. Okay, so this is about the ketone group. Next we will talk about the carboxylic acid. Okay, so carboxylic acid CH3COOH. This is a simple carboxylic acid, and name, since there are 2 carbons, the name is ethanoic acid. Then if I talk about CH3CH2CH2COOH, then here 1, 2, 3, 4 carbons, so name is butanoic acid. If I have benzene ring with COOH, so the name is benzoic acid. Okay, so this is a benzoic acid. Then if I have COOH, CH2CH2COOH, then here we have 2 acids, right? So but the main change Here we have 1, 2, 3, 4, 4 carbons. Okay, so since this is symmetrical, we have to write 1, 2, 3, 4. Okay, now here this acid is attached to this carbon, this acid is attached to this carbon. So the name will be butane, since there are 4 carbons, butane, and they are attached to, the acids groups are attached to second and third. So butane 2,3 dioic acid. Since there are 2 acidic groups, the name will be dioic acid. Okay, so butane 2,3 dioic acid. And then next we will take example of this. Okay, next is benzene ring. Okay, so this is benzene ring with 2 acidic groups. So here you have to start numbering 1 and 2. The main is benzene, so the name will be benzene 1, 2 dicarboxylic acid. Okay, so here the name is benzene 1, 2 dicarboxylic acid, since we have 2 acidic groups here. Okay, so this way we have to write the nomenclature, or we have to identify the groups here. One more example we will take here, that is benzene with CH2 COOH. Okay, so since this type of example we have also seen in ketone, here acidic group is attached to the aliphatic carbon and this acts as a substituent. So acidic group, now numbering will start from here. So 1, 2. So this at second carbon we have substituent as a phenyl. So the name will be 2-phenyl. Okay, since this is a substituent, 2-phenyl, and we have 2 carbons in the main chain, so it will be ethanoic acid. So 2-phenol ethanoic acid will be the name of this acid. Okay, and then if we will take one more example here. So this is one example, COOH and CH3. So the priority is given to COOH group and numbering will start from here. So 1, 2. So this group acts as a substituent. Name will be 2-methyl. Now this whole cyclic chain is of 5 carbons. So 2-methyl pentanoic acid will be the name. So 2-methyl, since this is pentane, cyclopentane. Okay, so 2-methyl cyclopentanoic acid. Okay, so pentanoic means aliphatic, which is open chain, but cyclo means closed. So 2-methyl cyclopentanoic acid will be the name. Okay, so this is the nomenclature of aldehydes, ketones and carboxylic acid. In next video we will come up with the preparation methods and other physical properties of these compounds. Okay, so till then you all revise with all the nomenclature of aldehydes, ketones and carboxylic acids, which we have done here in general. Okay, thank you so much, and yeah, we will continue in the next video.